welcome back to The Explainer. Today, we're stepping totally out of the rigid, grid-like world of traditional spreadsheets and diving into something way more dynamic. We're talking about document databases. Honestly, if you've ever felt completely boxed in by strict rows and columns when you're trying to store complex, constantly evolving information, you are absolutely going to love this architectural shift. So let's just jump right into it. To really get a feel for this technology, I want you to imagine a system that organizes information exactly the way you naturally do in the physical world. Think about how you organize the papers on your actual desk. You don't take a 10-page report, rip it up into single sentences, and then sort those sentences into 50 identical little boxes, right? No way. You keep the whole report together in one folder. And that intuitive, real-world grouping, that is the exact foundational philosophy we're looking at today. So formally speaking, a document database is a type of NoSQL database that's built specifically to store, retrieve, and manage document-oriented information. Instead of cramming data into really strict rows and columns, it stores structured, readable, and highly queryable objects. You'll usually see this done in formats like JSON, BSON, or XML. The cool part is that the database actually understands what's inside these documents, which lets you build out these beautifully complex nested data structures. Now, what's super interesting is where this tech fits into the bigger data picture. On one extreme, you've got your relational databases. Very powerful for sure, but they demand incredibly strict table schemas. Then, on the totally opposite end, you've got simple key-value stores, where the data is basically just a black box, an opaque blob. Document databases, they give us this perfect, intelligent middle ground. You get way more querying power than a basic key-value store, but it's far less rigid than a traditional SQL table. It's literally the perfect setup for evolving data. Section 1, the power of analogies. To really grasp this, let's break it down using some everyday examples.
Our first analogy from the source material is the HR21 file, your standard employee folder. Picture an HR department. Every employee has their own folder, and that folder is basically our document. Inside, you've got a resume, some performance reviews, maybe a few memos. But here is the absolute kicker. Two employees' folders do not have to contain the exact same paperwork. One person might have a specialized training certificate while another just doesn't. In a document database, all these unique folders lived happily together in a collection, allowing for totally flexible, varying structures without breaking the whole system.
Which leads us right into our next analogy, the social media profile. Think about your own Instagram or Facebook profile. Your profile is essentially one single document. It contains your name, your photos, your posts, and nested right under those posts are the comments. All of this lives together in one seamless, valid document. If we were using a traditional database, you'd need separate, rigid tables for users, another one for posts, another for comments, and you'd have to digitally stitch them all together every single time the page loads. But here, the nested data lives exactly how it's meant to be viewed.
Finally, let's think about a shopping app, like Shopee or Lazada. A listing for a smartphone has specific fields, like storage capacity or battery size. But a t-shirt listing, that needs completely different fields, like fabric material and size. They are totally different attributes, but they're both product documents living in the exact same catalog. A traditional relational database would force you to make this massively wide table with dozens of blank, totally unused columns for every product that didn't need them. Document databases just let each product hold only the fields that actually matter to it.
Section 2, understanding key concepts. Okay, now that we have the concepts down, let's translate those metaphors into the actual technical architecture running under the hood. At its core, the database uses a pairing system. You have a unique key, think of it as a document ID like 1234, and that's mapped to a value. But here's the magic. That value isn't just a single word. It holds the entire nested JSON object containing all the related data. So that's John Doe's name, his email, and a nested list of all his past orders, all in one chunk. Instead of joining 5 separate tables just to load one user's profile, a document database keeps everything neatly contained, totally readable, and super organized in just one place. And this brings us to a massively important concept, schema flexibility. Seriously, this is a total game changer for apps where data is constantly changing over time. Let's say you launch an e-commerce catalog today. Tomorrow, you decide you want to add a warranty period field, but only for electronics. Well, you just do it. You don't have to rebuild the entire database schema, and you definitely don't have to alter the clothing items that obviously don't need a warranty field. The collection just effortlessly adapts. But honestly, what good is all this flexible data if you can't actually find it when you need it? That's where indexing steps in. Unlike those pure key value stores we mentioned earlier, where you can really only search by that top-level ID, document databases actually let you create indexes on any field, no matter how deep it's buried inside the document. So for example, you could instantly query the database to find all customers whose city is listed as Manila, even if that city field is nested like 3 levels deep inside their profile document. Section 3 Real-world use cases. So with all this scheme of flexibility and deep indexing, where does this architecture actually shine? Who's using this in the real world? Because it supports such rich data models, it's become the go-to backbone for a few specific fields. First up, content management systems. Articles and web pages naturally vary in structure, right? Some have videos, some were just text. Second is e-commerce, dealing with those wildly different product attributes we just talked about. Third is IoT, the Internet of Things. Sensor readings and metadata vary constantly and need to be ingested super fast. And finally, mobile app backends and user profiles, where a free user and a premium user might have completely different data fields attached to their accounts. Section 4. The pros and cons. Now, we have to be objective here. Every architectural choice in the cloud comes with its own unique set of trade-offs. On the pro side, you are gaining incredible flexibility, rich data models, and massive scalability. Plus, developers love it because the database maps directly to the coding objects they're already working with. But let's look at the cons. Embedding all related data in one place can absolutely lead to data duplication. If you embed a customer's home address into every single order document they ever make, and then they move, you have to update that address in 50 different places, which can cause some major consistency headaches. Also, while querying is great, highly complex multi-layered queries just aren't quite as powerful as traditional SQL joins. So yeah, there's definitely a learning curve to designing these documents the right way. Section 5, Top Database Tools. All right, if you are itching to start building, let's take a look at the heavy hitters developers are actually using today. MongoDB is basically the undisputed powerhouse in this space. It's a wildly popular open-source document database, and what really makes it special is its proprietary query language, MQL. It allows for incredibly advanced filtering, sorting, and aggregating right inside your nested documents. You can easily write a query like find all orders where quantity is greater than 1, and it executes with massive performance and scalability. Next up, we have Firebase, specifically Firebase Firestore. If you're building a backend for a mobile app, this is huge. It uses document storage to give you instantaneous real-time data syncing. Literally, when a user updates their profile picture on their phone, the document updates in the cloud and instantly pushes that change to any other device currently viewing that profile. It's pretty amazing. And for true massive enterprise scale, we're seeing really robust managed services. There's Amazon Document DB, which is AWS's fully managed MongoDB-compatible service. And we also have Couchbase, another major player that's known for powering robust web applications and handling extreme performance caching. These tools really prove that document databases aren't just some fringe niche concept anymore. They're absolutely foundational to modern cloud infrastructure. So as we wrap up this explainer, I really want to leave you with one big question to chew on. Is it time to finally unbox your data? We've seen firsthand how schema flexibility, rich nested documents, and deep indexing solve real problems that traditional relational databases just flat out struggle with. As modern apps demand more and more evolving, semi-structured data to power these highly personalized experiences, the question really isn't if you'll need a document database, it's when will you make the switch? Thanks so much for joining me on this deep dive, and I hope this helps demystify the incredibly dynamic world of document databases for you. Catch you next time.